This lecture is about the latent aspect rating analysis for opinion mining and sentiment analysis. In this lecture, we're going to continue discussing opinion mining and sentiment analysis. In particular, we're going to introduce latent aspect rating analysis, which allows us to perform detailed analysis of reviews with overall ratings. So first, the motivation. Here are two reviews that you often see on the internet about a hotel, and you see some overall ratings. In this case, both reviewers have given 5 stars, and of course there are also reviews that are in text. Now, if you just look at these reviews, it's not very clear whether a hotel is good for its location or for its service, and it's also unclear why a reviewer liked this hotel. So what we want to do is to decompose this overall rating into ratings on different aspects such as value, rooms, location, and service. So if we can decompose the overall rating into ratings on these different aspects, then we can obtain more detailed understanding of the reviewer's opinions about the hotel. And this would also allow us to rank hotels along different dimensions, such as value or rooms. But in general, such detailed understanding will reveal more information about the user's preferences, the reviewer's preferences, and also we can understand better how reviewers view this hotel from different perspectives. Now, not only do we want to infer these aspect ratings, we also want to infer the aspect weights. So some reviewers may care more about values as opposed to service, and that would be a case like what's shown on the left for the weight distribution, where you can see a lot of weight is placed on value. But others might care more about service, and therefore they might place more weight on service than value. Now, the reason why this is also important is because if you think about a 5-star on value, it might still be very expensive if the reviewer cares a lot about service, right? For this kind of service, this price is good, so the reviewer might give it a 5-star. But if a reviewer really cares about the value of the hotel, then the 5-star most likely would mean really cheaper prices. So in order to interpret the ratings on different aspects accurately, we also need to know these aspect weights. When they are combined together, we can have a more detailed understanding of the opinion. So the task here is to get these reviews and their overall ratings as input, and then generate both the aspect ratings, decomposed aspect ratings, and the aspect weights as output. And this is a problem called latent aspect rating analysis. So the task in general is given a set of review articles about the topic with overall ratings, and we hope to generate 3 things. One is the major aspects commented on in the reviews. The second is the ratings on each aspect, such as value and room or service. And third is the relative weights placed on different aspects by the reviewers. And this task has a lot of applications. If we can do this, and we would enable a lot of applications. I just listed some here, and later I will show you some results. And for example, we can do opinion-based entity ranking. We can generate an aspect level opinion summary. We can also analyze reviewers' preferences, compare them, or compare their preferences on different hotels. And we can do personalized recommendation of products. So of course the question is, how can we solve this problem? Now, as in other cases of these advanced topics, we won't have time to really cover the technique in detail, but I'm going to give a basic introduction to the technique developed for this problem. So first, we're going to talk about how to solve the problem in 2 stages. Later, we're going to also mention that we can do this in the unified model. Now, take this review with the overall rating as input. What we want to do is first, we're going to segment the aspects. So we're going to figure out what words are talking about location, what words are talking about room, condition, etc. So with this, we would be able to obtain aspect segments. In particular, we're going to obtain the counts of all the words in each segment. And this is denoted by C sub I of W and D. Now, this can be done by using seed words like location and room or price to retrieve the relevant segments. And then from those segments, we can further mine correlated words with these seed words. And that would allow us to segment the text into segments, discussing different aspects. But of course, later, as we will see, we can also use topic models to do the segmentation. But anyway, that's the first stage where we would obtain the counts of words in each segment. In the second stage, which is called latent rating regression, we're going to use these words and their frequencies in different aspects to predict the overall rating. And this prediction happens in two stages. In the first stage, we're going to use the sentiment weights of these words in each aspect to predict the aspect rating. So for example, if in the discussion of location, you see a word like amazing mentioned many times, and it has a high weight, for example here 3.9, then it would increase the aspect rating for location. But another word like a far, which has a negative weight, if it's mentioned many times, and it will decrease the rating. So the aspect rating is assumed to be a weighted combination of these word frequencies, where the weights are the sentiment weights on the words. Now, of course, these sentiment weights might be different for different aspects. So we have for each aspect a set of sentiment weights, as shown here, and that's denoted by beta sub I and W. In the second stage, or in the second step, we're going to assume that the overall rating is simply a weighted combination of these aspect ratings. So we're going to assume we have aspect weights denoted by alpha sub I of D. And this would be used to take a weighted average of the aspect ratings, which are denoted by R sub I of D. And we're going to assume the overall rating is simply a weighted average of these aspect ratings. So this setup allows us to predict the overall rating based on the observed word frequencies. So on the left side, you will see all these observed information, the R sub D and the counts. But on the right side, you see all the information that we're interested in is actually latent. So we hope to discover them. Now, this is a typical case of a generative model where we would embed the interesting variables in the generative model. And then we're going to set up a generation probability for the overall rating given the observed words. And then, of course, then we can adjust these parameter values, including betas, R's, and alpha I's, in order to maximize the probability of the data. In this case, the conditional probability of the observed rating given the document. And so we have seen such cases before in, for example, PLSA, where we predict the text data. But here we're predicting the rating. And the parameters, of course, are also very different. But if you can see, if we can uncover these parameters, that would be nice, because R sub I of D is precisely the aspect ratings that we want to get. And these are decomposed ratings on different aspects. Alpha sub I D is precisely the aspect weights that we hope to get. As a byproduct, we also get the beta vector, and these are the aspect-specific sentiment weights of words. So more formally, the data we are modeling here is a set of review documents with overall ratings, and each review document is denoted by a D, and the overall rating is denoted by R sub D. And these pre-segmented into K aspect segments, and we're going to use C sub I of W and D to denote the count of word W in aspect segment I. Of course, it's 0 if the word doesn't occur in the segment. Now the model is going to predict the rating based on D, so we are interested in the conditional probability of R sub D given D. And this model is set up as follows. So R sub D is assumed to follow a normal distribution with a mean that denotes actually a weighted average of the aspect ratings R sub I of D, as shown here. This normal distribution has a variance of delta squared. Now, of course, this is just our assumption. The actual rating is not necessarily generated in this way. But as always, when we make this assumption, we have a formal way to model the problem, and that allows us to compute interesting quantities. In this case, the aspect ratings and the aspect weights. Now, the aspect rating, as you see on the second line, is assumed to be a weighted sum of these weights, where the weight is just sentiment weight. So, as I said, the overall rating is assumed to be a weighted average of aspect ratings. Now, this alpha values, alpha sub I of D, or denoted together by alpha vector that depends on D, is the document-specific weights. And we're going to assume this vector itself is drawn from another multivariate Gaussian distribution with mean denoted by a mu vector and covariance matrix sigma here. Now, so this means when we generate our overall rating, we're going to first draw a set of alpha values from this multivariate Gaussian prior distribution. And once we get these alpha values, we're going to use then the weighted average of aspect ratings as the mean here to use the normal distribution to generate the overall rating. Now, the aspect rating, as I just said, is a sum of the sentiment weights of words in the aspect. Note that here the sentiment weights are specific to aspects. So beta is indexed by I, and that's for aspect. And that gives us a way to model different sentiment of a word. This is needed because the same word might have positive sentiment for one aspect, but negative sentiment for another aspect. It's also useful to then see what parameters we have here. Well, I just said that the beta sub I and W gives us an aspect specific sentiment of W. So obviously that's one of the important parameters. But in general, we can see we have these parameters, the beta values, the delta, and then the mu and sigma. So next, the question is, how can we estimate these parameters? And so we collectively denote all the parameters by lambda here. Now we can, as usual, use the maximum likelihood estimator, and this will give us the settings of these parameters that would maximize the observed ratings conditional on their respective reviews. And of course, this would then give us all the useful variables that we are interested in computing. So now, more specifically, we can now, once we estimate the parameters, we can easily compute the aspect rating for aspect I, R sub I of D. And that's simply to take all the words that occurred in the segment I, and then take their counts, and then multiply that by the sentiment weight of each word, and take a sum. So of course, this count would be 0 for words that are not occurring in the aspect I, and that's why we can take sum over all the words in the vocabulary. Now, what about the aspect weights? Alpha sub I of D, well, it's not part of our parameter, right? So we have to use the Bayesian inference to compute it. And in this case, we can use the maximum a posteriori to compute this alpha value. Basically, we're going to maximize the product of the prior of alpha according to our assumed multivariate Gaussian distribution and the likelihood. In this case, the likelihood is the probability of generating this observed overall rating given this particular alpha value and some other parameters, as you see here. So for more details about this model, you can read this paper cited here.